Okay, so there's a few questions that I've covered, so you should be able to see everything. Yeah. So there are a few questions that I just kind of wanted to cover before we carry on. And before that, I want to look at the projects that I have now uploaded to Canvas or made available on Canvas. So for this week, you have two options for your project. Project one or option one. This is more for like beginners to intermediate students. I recommend to do option one. It's really the basics of covers the basics of the course. Well, you can read the description. Quiz. There we go. Okay. So as a researcher, you have to do some ETL and EDA skills on the movie data set and answer the questions below. So there's a whole bunch of questions you have to answer. And then at the end of it, create a GitHub repository and send the link for that the repository here. So this is, you have until the end of until the 5th of Feb actually to do it, which is next week Monday, to do that. And that is for, again, beginners to intermediate students. I recommend that. For more the advanced students, you have to do the Streamlit option 2. And this is really what anyone can do either option, but obviously we know from your registration if you have experience in Python before. But this is quite an open-ended project using your own research data or any data of your choice that you work in as a professional. You have to create a Streamlit app that showcases your research and your data. And a few examples of that, like a basic example of this, I can show you here maybe. Once it loads, it'll pop up. But and prizes will be awarded for the exceptional Streamlit presentation for the research. So outputs is pretty much just the Streamlit app link, the GitHub URL and repo. The repo must contain README that explains the Streamlit code. So yeah, so this is maybe a very basic example. This is at least the least that we would expect. You have some data and you're just presenting it, and somebody can maybe click on the data and make it editable. Something like this, right? This is the least we would expect, but obviously you won't get any prize for this. So yeah, so this is an open-ended project. You have until next week to do it. Your research data or anything along those lines you can present. And yeah, and there will be prizes for exceptional presentations. So it's open-ended. So again, if the initial first few days of this week is too kind of basic for you, then you can start on a project, either one really. Okay, so that is the two projects. So again, if you go to this is available now, so you can under two project options, option 1 and option 2. So you can begin with that if you want. Okay, and yeah, there was a few questions about people had on the chat, which I'll respond to. The one says, is it possible to read a text file using pandas? I see there are many other options of files we can read, but a text file is not mentioned. Okay, so yes, you can read a text file. So text files are known as a flat file, like a CSV file. There's no really formatting or anything that is part of that file. It's just the data that you are representing. And you will still use a read CSV command for that, right? So I have an example of a flat file. And there's two aspects of that we're going to cover, which we didn't do before. So this is geospatial data. This is data we had from one of last year's students. Okay, so this is what the data looks like. So this is a text file, so we're going to use read CSV as well. But is there anything unique that you can see in this file that might give us a problem, or anything anybody can see? how this data is represented. Sorry? Yeah, the delimiter, right? So this is a semicolon, not a comma that CSV file would typically expect, right? So, but we can easily get around that. That's not a problem. And yeah, there are other, issues with this file. For example, the it's not really issues, but it's conventions which can give you problems down the line. So there are spaces in the file name, sorry, in the column names as well as the file name as well, which we can change afterwards as well. But let's first try and read in this file. Okay, so say file equals pandas dot read underscore CV. And this is what let me just copy and paste it so I don't make a mistake. Geospatial data text file. Okay, so let's first see what happens. First, let's see what happens if we just try to read it in like that. If anybody wants this data, I can put it on. Just let me know. Read it in, it'll say, okay, there's a tokenizing error, blah, blah, blah. So what it's complaining about is the semicolon. It's expecting a comma, but we can just get around that by just saying separator equals colon. Everybody's in the way, something like that. So we're just specifying that it should be a semicolon and not a comma. If we run it, then we get all our data as we expect. So output. Oh, we're not printing anything. File. File. There we go. Right, so there's our output, right? It's nicely sorted. And if we go to Variable Explorer, click on it, and there's our data nicely represented. The Variable Explorer also gives you like this color code, like heat map for this like a min-max representation as well. So you can find out what that means. But and in case this text file was easily read in. And again, we just had to specify the delimiter to be a semicolon. Okay, so the other question was, what does the open brackets like info and describe mean? So again, as I mentioned with the print function we did before, these square brackets inform you that this, for example, if we have say file.info, so this tells us that this is a this will perform certain operations on the file data itself. It's called a function, but more accurately, it's called a method. If you want to be accurate in terms of the pandas terminology and software engineering terminology, it is called a method, but it can get inputs if you want to. It has certain parameters that can input. That's why you have the open brackets. But because we're using the default parameters, we're not putting anything in here, but we can add, we can put stuff in here as well if we want to. So that's why we have anytime you see a round brackets, it refers to a function or certain operations that will be done to whatever file it's attached to. So this is what the dot a symbol allows you to do certain functions or operations to the file data. Okay, then the other question was, this was previously, somebody said about that when we were defining the variables, we said you can maybe split up the variable names. If it's premature, less 6 months, and then say yes. And then for each category, you can, explain it, which is one way to do, so I can do that. May you please repeat the steps to display the awesome visual that you displayed. So I don't know what awesome visual you're speaking about. Maybe it's a variable explorer. I don't know. So you have to maybe be a bit more descriptive. That. And the housing data last column is less counts than others. Should I have 505 counts? Okay, so let's look at the housing data again. There's a housing data. Iris, insurance, diabetes, housing data. Okay. So another useful feature, which is similar, if you know Jupyter Notebook or Jupyter Labs, you can run, if you just want to run certain lines of code and ignore the rest, you can. So this is print file.info. So if I can remember, it should be, is it this one? Count line. Yes. Yeah, 500. Yeah, that's the one. So if you just want to run just these lines, ignore everything else, then you can do that. So I think you're referring to 451. Yeah, so most likely, so this column, a non-null count, there are probably nulls in this column. That's why it's saying it's not 505 like everything else. So if you go to housing data, files, housing data, like probably empty columns or something in that file probably. Okay, let's look at the actual variable explorer. Doesn't help much. Last column. Yeah, there we go. So these are nans or empty fields. So that's why it doesn't count as a actual data set or an actual value. That's why it's 451. So hopefully that answers that question. But it's a good thing to notice about that. All right. I think that was all the questions up here. Yeah, so that's all the questions I had there. So yeah, Langa, about your question, but just showing the first and last column. Yeah, we will get to sorting and filtering the data. We're not going to do that just yet. So we will get to how do only see first and last or only range of data when you all rows of columns. We will get to that. Okay, so the next thing was to ask for some examples of other research specific data. So I have this over here. So I have this air traffic CSV data. So everything looks quite good here. It's well labeled and everything else. But I do notice something which is interesting. So let's read in this data. So let's say file equals pandas pandas.read CSV. And then one slight change is that you notice that my file pandas.01 is in a different directory, right? I created a folder called chat files from the chat, and I put all those new files in here, right? So if I say air traffic.csv, let's copy it, put it here. If I try to run that, it'll give me an error, say files not found in the directory. So all we have to do is say it is one directory. It is in a directory called chat files, like that. And then it should work. There we go. So I'm just saying, putting the directory, it's in a directory called chat files, and then the file itself is there. So now let's look at, I wanted to say print file info. I wanted to have a look at this. See if everything was read correctly in. Okay, so these are all objects, which means they are text. So let's just look at the variable explorer. So this is air traffic data. So I'm not sure what this data refers to. Maybe the person that uploaded it can explain it, but this data, if you want to sort it or filter it, will probably be a problem because these columns, DOM packs, INPACs, packs, they regarded as strings, like rather as text. So you can't maybe sort it or filter it, maybe a certain range. Are these like coordinates? Maybe somebody that knows what the data is can explain it to me. Are these coordinates or something along those lines? So again, this data isn't this is very useful because it's regarded as text or string. So this is something, you know, a good example of how do you modify the actual data to make it numeric, so we can filter it, sort it, you know, however we want. So anybody knows what this data is? I can't remember who uploaded it, but just explain to me what these values mean, and then we can look at it. The other one was jobs in data. I think this one was actually fine. I didn't see anything. Pretty standard. It's labels for columns are pretty good, and everything else seems well sorted. So I'm not going to look at this data. Network data. This is quite a large file, about 22 megabytes, which is still worthwhile to work with. Once you start using bigger files, you're going to have problems because it's stored in memory. But we'll speak about big data at some point if there's interest in it. But yeah, so I didn't see any issues with here. Everything seems numeric. So I won't worry about that. And SpecBoom as well. Everything seems fine here as well. Looks like categorical data in the first column, and then numeric data in the second. So I won't really worry about that. Okay, so yes, again, you can upload your data. Oh, there's one interesting file I got, which was this one over here. This is an Excel spreadsheet that somebody uploaded, which I wanted to use an example. So one of there are limitations to a spreadsheet, and sometimes we use it beyond the use cases for what it was designed for. We use it for like a notebook to explain ideas or principles, or and we use it a lot to add metadata to it or data to explain certain things. So, which is fine, as long as you don't plan to use it in an analytical software program or statistics program, or want to load it in Python. So if you want to, load this in Python, it will be a lot of issues with this data set, or with this kind of how the data is structured as is. Can anybody give me this, for examples, why this will be a problem to read into pandas or any other statistical program that you might run? Any ideas, any comments about this? So again, when we want to run up any simulation or reading our data, we want to kind of keep it in a flat format, right? So there's no formatting. We have to give clear instructions to the program exactly what the data is, be consistent with the number of columns, with the names, and how the data is stored. So obviously we cannot translate highlights. As you see, some of the row cells have highlights. You can't really translate that very easily to pandas or any programming languages. And also you'll see the dates is something we'll discuss as well, which is important thing to mention here while we are on it. How dates are stored can change between laptop to laptop, version of Excel to various other versions of Excel. So trying to make sure your date is as verbose as possible is a key part of storing your data. So we'll look at examples of how to even make sure that whenever you store your information, your date or time, anything is as clear as possible for your program to understand. So that's one thing I could clearly see. and also mixing numbers with character letters or anything like that is also problematic. But again, if this data set wasn't designed to work with, programming language, it's fine. It's more of as a notebook kind of a spreadsheet. There are ways to translate this into something that programming language can interpret. But it's just important to note how your data should look. So thank you for that. Okay, so we're moving on. Where are we now? Where are we now? So what is the last thing that we did? Can anybody remind me what is the last thing that we did? UCT is too shy to answer, so I want to ask UCT. Anybody in the chat maybe can remind me what's the last thing that I did? In the lesson. Can nobody remember? Normally, do you remember what I did? Yeah, I was just adding a heading for that, yeah. So that was, look at the notes so far. This was, yeah, it was this section over here. We did pretty much last, and we did a few examples. And I asked everyone to upload the data. Again, any data you can upload. It's not a problem. CSV, Excel, text files, HDF5, other formats as well, JSON, XML, any kind of data that you work with. If it's a large, anything more like a few megabytes, then rather just send me a link of your GitHub repo of your data. All right, so this is a browser option. This is if you want to upload data and run it in a browser. It's pretty much the same process. So I can go through the notes to check that out. Won't cover that anymore. So next thing is, looking at storing data in Python. Okay, so we've actually covered quite a lot in a short space of time. And in many introductory courses to Python, you wouldn't even get to pandas yet. You wouldn't even get to reading in CSV files. But hopefully everybody was able to do the steps. I mean, you literally need to, as first example, literally like 3 lines of code to get to something, right? You might not know what each of those lines mean just yet, but at least you've got something working on your own. And it's important just to know that you can get that in your own data as well. So again, we're not, we're going to go into a bit of depth into a bit more skills on how to understand how to store data as well, because that's important. And also what type of, how is this data actually stored in Python, and specifically using pandas, okay? So let's create a new file. What should we call the file? Can anybody give me an idea what to call the file? The section we're doing is storing data in Python. So what should we call the file? Data storage, okay. Okay, let's create a new one. We call it data storage. Save it. Say data. The same name convention we need to follow. With file names, like file variables. Don't have spaces. We're using snake case, so data storage. You can be as verbose as you want with variables. I mean, as long as there's not like 10 words in it. But as 6 months down the line, you should go back to your files and your data and see your variable names and file names kind of make sense. So try and do that. Thank you. Call it bamboo because pandas eat bamboo. That is true. However, it doesn't give us a clear indication of what we'll be doing. But maybe if we have bamboo data, I can call it bamboo. Yes. Okay. So we are covering, we are doing data, storing data in Python. Storing data in Python. Okay, I'm going to clear all these variables because I don't want them anymore. So I go to Variable Explorer and it's all gone. So we're going to look at a few different types of data storage. So we're going to look at lists, look at dictionaries briefly. And what's associated with pandas is data frames. So if you're familiar with R, you should be familiar with these terms as well. But it's pretty much a tabular format for storing data. Okay, so those are the three main types of ways to store data that we'll discuss. There are other data storage means in Python, but we're going to just focus on these. And again, data frames is specific to pandas. Okay, so okay, I'm going to go back to the example I had before with the country data. So where's my country data? Country data, and actually, I don't really want to run it again. Do this, copy and paste. Don't have to type out everything all the time. Just get that up and running and get our data here. Okay, so we have country data, pretty basic data, age, gender, and country that we have an Excel spreadsheet, right? But let's take a step back and try and do this a manual approach. Let's try and input the data, from the ground up. Instead of assuming we have a CSV file, what happens if we want to input the data manually and create our own data in Python? How do we do that? Okay, so we were able to earlier this morning, we were able to get some examples of storing data, X and Y and name and everything. And we had mass and we had density this morning. But let's say, for example, we want to pull the data from scratch. So how do we do that? Okay, so let's say, for example, we want to create a variable for and store these values for age 39, 25, and 29, right? Let's say if we want to create a variable that can do it, we can say, for example, maybe like age 1 equals 30, age 1 equals 30, age 2 equals 25, age 3 equals 29, right, for example. All right, so you can carry on and do the same thing on your side where you're storing each value in a variable, right? But now assuming you have 1,000 variable names and data points, it's going to be quite a tedious job. And the whole point of programming is it can automate things and do things a lot quicker than it can do manually, right? We can run and save this file and see what we get. We go to Variable Explorer, we see age 1, 2, and 3 are all integers, and that's stored. Okay, but again, it's a bit tedious to do this if you want to create your own data. So and also we don't want to really say if we have maybe just 10 values like we have here. How about we create one variable with 10 values in it? Okay, so to do that we can use a list. And a list is quite self-explanatory. I mean, you can create a variable called age. And once you have square brackets, a square bracket is specifically defines a variable to be of a list format. And a list format can store a whole number of values, right? So I can say 30, 25, 29, and you can carry on. You can store as many values as you want, 46 and 22, right? You can carry on. You can also store any type of data type as well. Here stored integers or whole numbers. You can store other data types too. So what happens if you print this out? Print age. Print it out. You can see this is your output. Okay. Print age and you get your output for the numbers. So you can have 100 numbers, as many as you want. And this allows you to kind of create a variable that has many values in it. You can have text, floating numbers, or a combination. So it doesn't have to just be numbers. It can be a combination of other values. So for example, in age, I can also say, for example, I can say, maybe like 3.14, and I can also have, tau, right? I can store that as well in a list. So it doesn't have to be specific to that data type. But again, it's not good practice because especially when I do, stats on it, I mean, it's going to give you problems. So, but I just wanted to give an example. So the next step to obviously understanding, once you have a variable, sometimes you might want to access one value or two values or range of them. Okay, so how do you do that? So if you just want to access the first value, for example, you would say age. Again, if you want to access the value, you have to square brackets and you put 0. Okay, so what value do you think age 0 is going to give me? What value? 30. And why does age 0 give you 30? And why don't it say age 1? Yeah. So because the index or how the values are stored starts at 0. So this is a common in software engineering and computer science. The first element starts at 0, right? So I have a little figure here to give you maybe some insight. So we start at 0 for the first element, or the first value, and then until the rest 0, 1, 2, 3, 4, 5. Right, so that's why we say age 0, and then you can access that value. Okay, so if I say print that, then I'll get the value of 30. Right, so you should get 30 if you print it out. Okay, and the next element, if I want to get value 25, what do I need to print out? If I want 25, what do I say here? Not 0, but I need to add 1 here. Okay, then I'll get the value of 25, and as you go along, you can carry on. All right, so yeah, that's again if you want to access individual values of a list. This is how you'll access it. Okay. Now the nice thing about lists or Python itself as well, it kind of does the work for you, right? It has built-in features and functions to kind of make your life easy, right? So just like in Excel, you might want to find the minimum or maximum or sum of values. You can do that quite easily with built-in functions, right? So if I want to find the minimum value of this list, I can just say print a min brackets age to get the minimum value, and that prints out 22. Prints out 22. Right, so this is a built-in function in Python. It works with lists. And if you notice the round brackets, it's anytime you see a round bracket refers to a function or more correctly a method, and expects an input. That input is the age list. Okay, so it just works out the minimum list for you, number in that list. So you might think you also get a method called max as well, or function called max to work out the max value. So I can say max. You can also do sum. These are things you can try on your own as on the notes. You should get what you expect. And if you want to get, you can find the length in terms of the amount of elements in that list as well. So if you say length, all these things are built into Python, and you can work it out. Okay, so how do I work out? I know how do I work out the average number in this list? How would I work that out? How would I work out? I have this list over here. I want to work out the average number. You can type it in the chat for me, a little sum or variable. In the chat, you can type it out, what the code should be to work out the average number. So type it in the chat, work out the average number for this list. Okay, but I want the full code. So give me average. Okay, all right. Okay, so we have a few examples. So Zipo, I want to try your example. Average age. What does it say? No, Python or Pandas isn't going to make your life that easy. You have to work out the equation yourself. There is no average. There's no average functional method. This is a problem. You can't do it. You actually have to physically type out the equation for average and then print it out. So we have a few examples there. So we can say average equals, as we saw before, sum of age divided by length of age. Right, then print it out. This will work. Okay. That'll work out the average, which is 30.4. Okay, that's a simple sum you can work out to kind of work out the average for per list. Okay, so that is using lists with numbers, but sometimes you might not have numbers, you might have text, right? So the same way we did before, we had if we take gender here, maybe have like say G1 equals male, G2 equals female, F for female, and then G3 equals male again, right? If you run that, it gives an error, it shows undefined name. It's expecting double quotes because it's a letter. You need double quotes with a string or text. And then you can save it like that, right? But again, if you have a lot of values, it's tedious to create an individual variable for something like this, right? You rather create a list for gender, brackets, and it say male, female, male, right? And as it goes on, right? So in the same way, you can access the values in the same way, and work it out. Obviously, you can't find the average here. You would have to convert this maybe to, if you want to find that, you could have to convert each value to numerical value, 0, 1, or 1 and 2 maybe, or there are ways to work that out, but it'll be challenging in this way. Yeah, and then the other example on the notes was just using, if you want to store country, like C1 might be like, South Africa, C2 equals, Lesotho, right? So in the same way, you just create a list called country list, then, add all the country names in there. Okay, so The example is just really just to show you using list. If you have a lot of values, you can store that in one variable, and you can use lists to do that. So one thing to kind of know about list is it has kind of built-in features that it can use as well. So I'll just delete that. So sometimes you want to maybe access a range of values, maybe not just the first or last one, a range of values. So maybe let's go back over here. Let's use an age example. So let's say, let's go down here, so print age again. And then we're going to say we want like a range, or maybe like the first three values, right? We can say print age, and we're going to use square brackets and just specify a range from certain numbers. 0 and then colon, right? And then the last number that you want. So maybe make it 2, for example. Print it out, and it gives you 30 and 25. Okay, but now somebody might say, but that isn't 3 numbers, it's only 2 numbers. And that's right, because this value, this 2, is not the it's n minus 1. It's the end of the range minus 1 that it'll give you. So the full number is full number in the list is until 22. So if you want 29, you would have to say 3. Right, and then you get 29. So this last value will be the value in the list minus 1 will give you that certain range. So that's a useful thing to know if you want only a specific number of values in your list. Yeah, in the notes it discusses inserting and appending values. So sometimes if you want to maybe add values to your list, let's say age dot, you have used the dot append method or function. So maybe like 100, something like that. Print out age again, and you should see now your list has a new number added to the end of it. So append is something probably you'll use a lot in most cases. You can remove numbers and you can remove specific values, for example, if you have text in it, but that's all in the notes. I mean, feel free to ask me questions about lists as well if you plan to use them, or if you want to know more about them. But again, this is a more of an introduction to the pandas data frame, just to give you context of how it works. So we're only covering lists and dictionaries, but primarily we're going to work with the pandas data frame. So this is like a bit of intro on how data storage works and how to access it before we get into data frames. But yeah, it's just good to know. And yeah, so I think it's 3 o'clock now, so time for our tea break. If you have any questions or content to add, any data files, please put in the chat. So yeah, we'll stop now for a break for 15 minutes, and then we'll start again. Thank you.
Some of them might be doing it.
Okay, so our last 45 minutes of today. I was able to, well, from normally, to increase the size for the console, so should be able to see it now. I want you to copy all this. I want you to copy it all the time, so just make sure if the console looks better now, you can see it, better to read. Or if I must make it even bigger. The other thing is, kindly explain the purpose of the 3 inverted commas, double quotes, we're not to use them. So I'm just using them for like comments, just to explain what I'm doing. Python will just ignore it. So you can use it as you want. I don't need to have any of the comments as well. It won't change the code in any way. It's just to kind of explain what I'm doing in the code. So hopefully that answers that one. Regarding the naming of the housing data, did anyone get a breakthrough? So I think we did cover it before in the previous lesson where we can just say if we commented there, but if you want to add names, you just say names equal, no, we're using a list like A, B, A, B, and C, whatever other names you want. And then for that file, we say pd.read CSV, read CSV, housing data .csv, and then to change the names, or to give it names, actually is more correctly saying. You just say names equals names, or maybe this might be easier for you to understand. Square brackets and then A, B, C. So A will be column 1, B will be column 2, and so on. So this is how you can give the column names to a file. Why is it complaining? Undefined. Oh goodness, bad habit. Oh, it is a good habit, but right. So this is how you can give names to the headers if it doesn't exist. So hopefully that explains this question over here. And then another question: how do we append the number 100 in the first position? So this is in the notes, but I will do it since I was asked. So just comment this out. Let me put this, I'll put this over here if you want to still see it. How do you append number 100 to the list? So let's just get this. So let's put age again. So there we go. So we're currently printing age. This is what you get. So this is all the other stuff we've done before. This is why we're getting that, right? So if you just look at the last output, refers to the last line, which is over here. So how do we do that? So we can just use a insert method. So we say age.insert 100, well, a position 0, value 100. Okay, now let's say run it. To be honest, I don't actually have to say print each time if I want to modify, edit. This is why I have a variable explorer, right? I can actually see it already. So if I go to age, I mean, it's there already. You can see 100 was added. So if you click on age, you can see it there as well. 100 was added and everything was just shifted along, right? So that's how you can insert a value anywhere in your list and update it. So yeah, so hope that answers the question, and I'll add this. I'll add this to that over there. So if you still want to see it. Okay. Okay. Can somebody respond to Eunice, please? We all have experts here, so somebody can just respond to them, to Eunice, just to help Eunice out. All right, so the next section we're going to cover is briefly dictionaries, and hopefully we can get to data frames, which is ultimately what you want to work with. Where are we now? Exotoplasm. So we are down here, almost done with this lesson. Okay, so we're going to cover dictionaries. This is where we currently are going to briefly discuss dictionaries and how they work. Okay, so dictionaries. So what is a dictionary? A dictionary is a collection of key value pairs. Always wondered why they called it a dictionary. Key value pairs. If you think about a dictionary, if you look at a word, so give me any word. Any word in a dictionary you might think of, and maybe an explanation for it. Any word in dictionary. Sorry? Cat. Okay, so in a dictionary, look up the word cat and you'll get some explanation. What is a cat? Okay? Oh, I need some more, but give me more information about a cat. A cute animal. Okay, I like that. I don't know what kind of dictionary that is, but okay, a cute animal. Cute animal. Okay. So it has a key value, or it has a, for example, cat, and it has an explanation, a cute animal. Okay. So this is what we know, or in this sense, a key value pair. We have some word called cat. It can be any word that you want. And then it has some description or some value associated. So here it means a cute animal, a cat. And you can have anything, right? Associated with it. But it's quite different to a list because it doesn't have an index, which makes it quite powerful as well. So if you're familiar with arrays or hash maps in other programming languages, this is quite similar. So it is also important to note that they are unordered. Unordered, unlike the way a list you can or different structures. So let me just not mention that just yet. It's going to be confusing. So how do you create a dictionary? Okay, so give me a name for a dictionary. Give me a name for a dictionary. Primarily domain specific, so not just cat, but something domain specific to your area. Make it more interesting. Mammals. Mammals. Okay, mammals is a good example. Mammals. Is that how I spell mammals? Okay. M-A-double. Like that. Really? I forgot that. Okay, mammals. Okay, so so to create a dictionary, you don't use square brackets, you use curly brackets. Okay. So, and how do you define values in your dictionary? So we had, for example, we had cat. So now we can say, okay, well, we're going to define it as, let me do double quotes just to be consistent. A cute animal. Okay, can I have another example? Another example for a mammal? A lion. Okay. So again, lion, and quite different to a variable where we use equal signs. Here we're using a colon to assign the value or the value to the key. A key has a line. So how do you describe a line? Sorry? King of the jungle, king of the jungle. Okay, and one more example. Sorry? Another mammal, please, on the chat. Anyone, give me a mammal. Elephant, okay, elephant. Okay, how do you describe, is a dolphin a mammal? Okay, somebody said, okay. Okay, so how do you describe an elephant? How do you describe elephant? A gigantic, what? So we'll do like one word, other person does another word. A gigantic what? Herbivore. How do you spell herbivore? Herbivore. Is that how I spell herbivore? Goodness, okay. Yeah. Somebody said a pachyderm. What's a pachyderm? What's that? Eunice, what's a pachyderm? Pachyderm. I don't know what that is. Please explain. Okay, so this is how we create a dictionary. We have some name for a for the key that you want, and then describing it in any way. We can also have numbers. We can have numerical values as well, which we can use another example later. But let's run this and see what we get. Okay, again, I'm not going to print this out to the console because we don't really need to. This is the nice thing about Spider, is we have a variable explorer here. So we have mammals. So we can see our data. It's right in front of us. We don't have to remember it like in other programming languages where it's kind of hidden somewhere in memory. We have our data and it's stored quite nicely as a value. Somebody shared, oh, a pachyderm is a very large mammal with 6 thick skins. Okay, never knew that. Thank you, Eunice, for that. I never knew what that was. Now I do. Okay, so now we can create a dictionary. Now, now how do we say we have like thousands of examples of mammals? I'm not sure if there are 1,000 mammals, but for example, now how do we access, just like in a dictionary, we're going to flip through the letters until we get to A or C, whatever, then we kind of figure it out. But now Python makes it easier for you to kind of figure out, you know, I have 1,000 mammals. I want to know what a cat is or a lion is. So how do I access that specific information? So we can just say print. So we access the mammals. We access the mammals dictionary. And we square brackets. And we say stick to double quotes. And we say cat. So let me just do this. And we see the answer gives us a cute animal. Okay. So again, this is a very simplistic example, but just shows the power of Python and specifically dictionaries. Imagine you have maybe you have a long list of student names with the details or other specific information. You can access it quite easily by storing it as a dictionary and then accessing it as a key value pair. So the example we gave here is with like a person's name, their age and address. And maybe you just know the address, you want to find the person's name, and things like that. So there's many ways to work with dictionaries, but I just wanted to give a bit of an idea of how it works, because it's quite important to understand that basic principle in programming in general, as well as in Python. But again, our main focus is going to be on Pandas data frame, okay, which is the next section we're going to cover. So data frames. So data frames. So ideally, when dealing with tabular data, the Pandas library provides you a very versatile structure called a data frame. So again, if you're familiar with RStudio and R programming, then you should be familiar with the data frame. It's 2-dimensional. It can be series as also a single column of data. And it gives you like a labeled data structure. And it's similar to a spreadsheet or even a SQL table as well. So in Pandas, you can read in SQL data. If you have that, if you're familiar with SQL and relational databases, you can read in SQL as well. Anybody has examples of SQL data, you can share it, you can upload it. So we can give an example of it. But the Pandas data frame is quite versatile. And this is, if you're starting with programming, try and focus effort on learning this type of data frame from the beginning. Okay. So we've already done importing data. We know how to do that, and we can probably do that with our own data. But how do you create your own data frame? So there's a few ways. So previously we just learned about dictionaries and lists. And to create your own data frame, it's kind of uses a similar principles, right? So let's maybe create, can somebody give me again, domain specific, a list, give me the name of a list, and data in that list, right? So you can put in the chat, maybe it'd be easier for me to copy. So if you give me like five values and the name of a variable of a list. So 5 values and a variable name for that list. Domain specific. Waiting for a few people to input something. I have fruits, which is okay. Okay. Okay, all right. Okay, I'll use fruits, but that's the example we have. So I'm gonna have fruits, right? So this is a list here. Tabu, you need to give me a list so I can just copy and paste it. Nobody's gonna wait for me to type out 5 numbers. So I need a list. So Christopher, thank you, Christopher, for making my life easy. I'm gonna go 2 lists here. Okay. So with that, I'm gonna create a size as nm as nanometers. Where's Christopher? Okay. So we have very small fruit, don't we? Okay, so that's fine. We've got 2 lists, and now we're going to create a data frame from that, right? So give me a name for the data frame. A name for data frame, UCT. Fruit sizes. Okay, that's a nice one. Fruit sizes. And just like we created a dictionary, we're going to create to create a data frame. One of the easier ways is just to create a dictionary, and then use one of Pandas methods or functions just to import it. All right, so we're going to say fruit sizes. We're going to curly brackets, and then we're going to say what is our or we can the key can be fruits as well. Doesn't make a difference. Fruits. And then the other one is sizes. So it's going to be Christopher, I don't like a capital S. That's not standard. It's fine, but I mean, not standard. Okay, so created a dictionary. And now what do? We go, we're going to create a data frame. And the standard, everywhere you see in Pandas tutorials, you see DF, right? DF just stands for data frame. So people might see my comments. I'll just say DF just stands for data frame. So I'm going to create, instead of file, I'm going to say df for data frame, and I'm going to say pandas dot data frame, and input what's the fruit sizes? Fruit sizes. There you go. And again, I'm not going to print it out because the cool thing about Spider is what? Variable Explorer. Thank you. Run it. And where is df? Here we go. There we go. So we just created a data frame from scratch. Okay, so imagine you have thousands of data, 1,000 data points, created from scratch, maybe random numbers or random data you want to create from scratch. And this is one way you can do it. First, create a dictionary of the data, and just import it with pandas. So that's just one quick and easy way to be able to do that. Yeah. So there's another, as we're speaking about a few shortcut ways, there's another shorthand part of pandas which you should know about. Is that in most cases, if you look at tutorials or lessons or whatnot, they don't actually say import pandas. What do they actually say? As PD, right? So they don't say import pandas just as it is. They say import pandas as PD, right? And that's just a shortcut, an alias or shortcut way just to refer to pandas. Instead of typing on pandas all the time, you can just say PD instead. It's called alias or shortcut way, shorthand form of referring to. Just to mention it in the notes. I just wanted to mention it as well. So just to take note of that. I'll leave it, deleted for the time being because the rest of the code will probably break if we do that. So I'm sure you can actually add it again. Import pandas as PD. It shouldn't break like that. So if we want to read it in file, we can just, it should understand that it's or use PD instead of pandas. So with this example, maybe I'll use with PD. I run it, a data frame still there. Yeah, so that just should work. We've got a question here. Right. Okay, so okay, thanks. Normally, is that like as many people can answer that one? Hope so. Okay. Is it anonymous or not? Yeah. Other people will feel obliged or. It's fine. We could do another one tomorrow, just in future. Can leave it as it is. Yeah. So okay, we can create that data frame as is. Okay. So now this single data frame represents entire data set, or other data sets that you want to create. And this allows us to be more concise when you're storing data. And it's very straightforward to access any of these, certain columns or whatnot, right? So for example, if I only want to access the fruits data column, I can just say fruits, right? And that shows me the fruits column. Did I do something? Fruits, yeah. There's a column, apple, banana, all the columns there, right? So if we want to access a specific column, we can. Okay, and what about the other one? So let's see the DF, other one was sizes, right? The sizes, or did we say fruit sizes? It was just sizes, yeah. There's different sizes. So why I want numerical numbers is we can modify it. Let's just check if this is stored as data type. Okay, data type is a float, so we can do numerical, you know, get some numerical data from it. So for example, just like with lists, we can work out the min max as well. We can do that here. So for example, we can find the minimum value in this list. Sorry, in this, why is it giving me an issue? Oh. The minimum value, you can work with the maximum value. You can also work out the mean, right? So all these things that, so maybe just copy it again. Look at the mean as well. It can't work with standard deviation. You need another library for that, as far as I can remember, or you can work with standard deviation. But there's a mean for that. Can also, I mean, you can do describe as well if you want. df.describe. If you actually want all the statistics, descriptive statistics, or sizes. So you have two ways to access certain information, right? Okay, so I think what probably is something most useful for everyone is to, when you kind of filter the data, you only see certain sections of the data, right? So that's also quite easily accessible. So for example, again, this will be more catered for our numerical data. If you want categorical filtering, you can do that too. But if I want to, for example, only see the first, you know, if I want to see, well, let's see what data we have here. For fruit, where's the data frame? So maybe give me, if I only want to see fruit sizes that's larger than, for example, 10, for example, maybe that's a certain range I want to see, right? Only larger than 10. So I would say, okay, well, let's access the fruit sizes. So that'll give me access to all of them. And then I'll have to say, kind of create the data frame again. So let me rather do it like this. So data frame. So ultimately what I'm doing is this. So my data frame, I want to filter it for all values larger than 10, right? But I need to specify, wait, there's a typo there, larger than 10. But I need to specify what column I want to work with. So I have to say df, and then it's the sizes. That should give me something useful. Okay, so that filtered the data for me. So I'm only seeing a certain range of data where it's, if it's larger than 10, then I get the fruits and sizes for that data set. So it's a subset of the actual data that I worked with. Another example that you might want to work with is if you want to see maybe certain rows, for example, rows 1 to 3, for example. I think that was an example in the chat as well. So df, it's like 1 to 3. In the same way we do this with lists, the same type of way where we have the colon to give you a certain range of rows. I can run it, and then you see that we only have, shows the first 2 rows. Again, because number 3 refers to n-1, the last value -1 you can access. Okay, so the last 2 examples I want to give you is if you want to add a new column of data or remove a column of data. So can somebody give me another group of numbers to add? So we have these at the moment. So give me a another column to add with values in it. Color. I think you've been helping us too much. We need everyone else, the UCT, to also give input. Anybody in the chat, give me another column with data in it, column name and data in it. Anyone else? Color fruits, okay, all right. Somebody hold it on. So we have color fruits. Okay, so how are we gonna do that? We're gonna say numbers, prices, okay, prices, okay. But if you're gonna give, I need numbers as well. I need numbers or values related to the data. So I need the full code. I'm not gonna type it out. So just copy and paste. Infection, interesting. Okay, but I need the data, please, in the chat. Okay, prices, thank you. Okay, so this is the example we have here of prices. It's a very small fruit, tiny fruit, we can't even see it. But maybe the rare fruit because they're so small. So what we're gonna do is we're gonna say, okay, we're gonna say df equals prices. And we're just going to, I can just do this actually. Run it. And let's look at data frame. And there we go. We've got a new column added to our data frame of the prices for the fruit. And now how do we remove a column? So the last thing we're going to learn today is just removing a column. So we can say, to do that, we just say df.drop columns, and let's say we want to remove we want to remove sizes, for example, we just say sizes. And in place equals true. Can anybody tell me what in place equals true? Why must I put that parameter there? I have to delete a column for all the experts in Python pandas. What does in place equal true mean? You can Google, you can ask ChatGPT, what does in place equal true do? What does it do? In place equal true. Well, let's see if it works. Well, it's gone, so it worked. Kind of. I want a better example what in place equals true does. It's a very specific parameter that you should use when you're deleting data. In place equal true. Ask ChatGPT, Google, whoever you want. Yeah, so either make it permanent to the existing data frame or not. Yeah, so if you want to remove a column, and sometimes I mean, you don't necessarily, if you have like maybe 100 columns or maybe 10 columns, you can, remove specific columns you want, or even when you're reading in data, with the read CSV command, you can also specify which columns you want to read in. But yeah, this is pretty much what it does. Yeah, so thanks Lumko for true means the data will be modified without returning a copy of the data to all the original database. Okay, that's fine. Yeah, so that's it actually for today. If there are any specific questions or any anything I must review, another 10 minutes, so put it in the chat. But otherwise, that is it for today. There might be some homework quizzes you'll have to do later today, but you'll be informed about that. But otherwise, thank you for coming today, and hopefully you'll benefit from the next few days. Thank you.
Network.
Okay, so if there are no other questions. There's two questions. I will cover, maybe I'll show the cover tomorrow. I can cover the question tomorrow, because it will benefit, these two questions, but if you have any other questions, respond.